We're now going live to Chile, to the Las Campanas Observatory. Hello, Las Campanas.
Greetings from Las Campanas.
Can you introduce yourself and tell us what you do at the observatory?
Hi. I'm Dave Ossip, and I'm the Magellan instrumentation scientist, which means that I'm responsible for the instruments that we operate on the twin 6.5-meter Magellan telescopes here at Las Campanas.
All right. Can you tell us more about your observatory? We're just coming back from the very large telescope a bit further north of you, I suppose. Where are you located?
Yes, well, it's actually a fair bit further north, several hours north of here. We're on the lower edge of the Atacama Desert here at Campanas. And the observatory was founded 40 years ago now by Carnegie, and started with the SWOPE, the Henrietta SWOPE 1-meter telescope, has been in operation since 1971. The DuPont 2.5-meter telescope has been in operation since 1977. And now we've more recently added in 2001, science operations began here at the Magellan 1 telescope, named in honor of Carnegie astronomer Walter Baade, and at our twin telescope next door in 2002, named in honor of Harvard benefactor Landon Clay. So the Magellan telescopes, which I'm most familiar with on site in my role as an instrumentation scientist, are twin 6.5-meter telescopes, a Gregorian design, so you have the primary mirror bouncing the light up to a secondary, coming down to a flat tertiary mirror, and able to feed any one of 3 instruments at any one time. On both telescopes, we're operating with 3 active instruments every night, supported for scientific observations.
And so these 2 telescopes operate separately, right? They're not coupled in...
Yes, they are entirely distinct, and the instrument suite on them is entirely distinct as well. So here at the Baade telescope, behind me to my right is Jorge Araya, one of our excellent telescope operators, and all of those screens in front of Jorge are control for the telescope itself. And to my left behind me, you can see Emily Schaller, as well as, well, there is Scott Shepard and Chad Trujillo. Scott is an astronomer at the Department of Terrestrial Magnetism at Carnegie, and his colleagues from Hawaii and from Gemini North Telescope have joined him here tonight for observations with one of our near-infrared cameras.
Oh, so tell us more about that. So you're in the middle of observations? I guess it's the middle of the night now.
Absolutely. Absolutely. We're having a wonderful night here. One of the things that really separates out the Las Campanas site is the extraordinary seeing that we have, the clarity with which we can separate objects in the sky. To give an analogy, if you're flying in an aircraft, a normal commercial aircraft at 10,000 meters, looking down at a golf course, and you imagine you're a telescope in grand parts of the world, if you look down, you could not even separate where there was a hole on one of the greens of the golf course. If you're at a good site where the seeing is something like, we'll say 1 arcsecond, which would be considered quite good anywhere in the continental United States or continental Europe, you'd be able to see the hole. Pick a hole, your favorite hole, the 9th hole, the 18th hole at the golf course. If the seeing improves to half an arcsecond or 6/10 of an arcsecond, which is what we have as a median seeing here at Campanas, you could see that there's a golf ball right next to that hole. And on extraordinary nights, like we happen to be having tonight again, where the seeing is now measured at about 1/4 of an arcsecond, you could mark with a felt tip pen blue and red dots on that golf ball, and you'd be able to separate the dots and actually tell what color they are.
That's amazing.
So it's the ability to separate targets that are very close on the sky, as well as the ability to put more of the light from these targets into a very small area of your detector. It increases the efficiency of the operation. If you improve your seeing by a factor of 2, it is the equivalent in efficiency to increasing your telescope aperture by that same factor. So here we're at Magellan with 6.5-meter telescopes. but with quarter arc second seeing like tonight, we would be as efficient as a 13-meter telescope with half arc second seeing, which would be considered excellent seeing anywhere else in the world.
Amazing. Yes, I think Las Campanas has this reputation of the best seeing in the world. So what are the science highlights from these telescopes? What are these telescopes mostly used
Well, let's see. Just tonight, Scott and his colleagues are looking at Kuiper belt objects, and with specific filters to isolate the water bands in the near infrared in order to look for, in a broad sense, spectral features in these Kuiper belt objects. I think that's about correct. Over at the Clay telescope is a continuation of a very successful ongoing program of planet hunters. It's Professor Dante Menidi from Universidad de Católica in Santiago, Chile, is on tonight. He's a collaborator with Paul Butler at Carnegie's Department of Terrestrial Magnetism, and one of the more successful groups in finding exosolar planets.
Okay. Is Dante at the telescope? He's a good friend of mine, actually, so I'm surprised that he's in
it's actually a student working with Dante is over there at the Clay telescope right now.
All right,
but at this point, Dante's not up here with us.
So say hello for me. And you prepared an image for us?
I will do that, certainly. Yes, there was an image prepared. It's actually an image of Galaxy NGC 1300 prepared by Lewis Ho as part of the Carnegie Irvine Near Galactic Survey, and it's a composite image. Their survey strategy has been to take images in multiple filters, BVRI as well as near-infrared filters, and composite them in order to look at structure in these galaxies. This is only one sample image of a sample of galaxies that now is up to 600 targets, with the idea being of studying mostly this contemporaneous group to look at the morphologies now, and then to follow up with spectroscopy from telescopes like Magellan to look at rotational and velocity variations in these galaxies.
That's quite exciting. I understand also that the Las Campanas played an important role in the story of the supernovae in 1987A.
1987A? Well, the fact is that it was the first reports of the supernova did originate here at Las Campanas. I would like to think that while 1987A itself was a very important observation and really opened another generation of astronomers to supernova studies, the more timely science in supernova research that's proceeding today are part of the Carnegie Supernova Project that are studying Type 1a supernovae and using them as the standard candles that really set the distance scale and the velocity scale for the universe. The fact that the universe is not only expanding but is accelerating, and the requirement of this mysterious dark energy to be the cause of this acceleration that we're seeing today.
All right. And what are your personal interests? I mean, tell us. You've been probably using these telescopes too.
My research interests actually match very well with what's happening at the two telescopes tonight. I study small bodies in our solar system, comets, near-Earth asteroids, Kuiper belt objects, particularly binaries out in our Kuiper belt. So systems like the Pluto-Charon system, where you have a satellite or a moon around a principal body, and the fact that we can separate things very close on the sky here at Magellan allows us to determine the orbits for those. The other area of my studies are exosolar planets, but unlike Dante and Paul, who do the hunting for these planets, I'm more interested in following them afterwards in transit studies of these, what are now Jovian mass planets found around other stars. But if we observe multiple transits of those bodies across the front of the stars, we actually can learn or can distinguish if there's another mass perturbing that observed planet in the system. And it's giving us a chance, or hopefully will give us the chance to look for objects much closer to Earth mass planets around these systems.
Well, exciting. That sounds like a good subject for the next couple of years to study.
Absolutely.
So I'll let you go back to your observations. I hope you'll keep
Thank
having
you.
these clear skies. Thank you very much for joining. It was a real pleasure
Thank you
talking
for
to all you
having
guys.
us.
And
It's a pleasure.
keep observing. Clear skies.
Will do. Thank you very much.
Bye-bye.
Ciao.
And one apology, we could not connect to the Shanghai Radio Astronomical Observatory due to technical problems with the video conference tonight. You're watching Around the World in 80 telescopes. Stay with us for the next stop in our world tour, the ESO La Silla Observatory.